Hi, I'm Gracie, and I'm going to be talking about nuclide representation. So grab your periodic table and let's go. Okay, so basically, nuclide representation is just a fancy way of organizing general information about an element, like the protons, neutrons, and electrons. The formula is this little AZX thing, where A is the mass number, Z is the atomic number, and X is the element. So here's what the formula means. A is the atomic number, which is the total number of protons and neutrons. Z is the protons alone, so you can subtract Z from A to find the neutrons. Additionally, if the element doesn't have a charge, Z is also the number of electrons. So here's an example problem. If you're ready to try it, go ahead and pause the video, but if not, I'll have another practice problem in a bit. Here's a breakdown of boron from the periodic table. Most periodic tables will have these numbers laid out like this, with mass number at the bottom and atomic number at the top. But if not, just note that the mass number is bigger than the atomic number in every case except for hydrogen, in which case both the atomic number and the mass number is 1. So here's the nuclide representation of boron. Yes, it does say 10 on the mass number, but since it's 10.811, we can round that to 11 for the mass number. Here's another question you might get with nuclide representation. Pause it if you want, but I'll have another of these if you don't know what to do yet. So the atomic number is simply the number of protons, so we know that just from looking at it. Now to find the neutrons, you subtract the atomic number from the mass number. And since there's no charge on boron, the electron number is the same as the number of protons. So here are a couple exceptions to the typical nuclide representation. First, we have isotopes. Isotopes simply have a different mass number than the typical atom, which may be more or less. Then there's ions, which are atoms with a charge. Listen up, this is important. The number of electrons change from the protons based on your charge. If the charge is a positive number, your electron number will go down from the proton number. But if it's a negative charge, then the electron number will go up. Just remember that electrons are negative, so if you're adding more negatives, it will become more negative. And if you're adding positive numbers to a negative number, it will become less negative. Okay, so here's some practice questions to sum up this video. Pause the video and give them a try. So starting with the first problem, we know that there's 16 protons in the sulfur ion, since the atomic number is 16. Then 32 minus 16 is equal to 16, so that's also the number of neutrons. Now remember, the charge means that it's an ion, and the electron number will be different than the proton number. As I mentioned before, a negative charge makes the electron number go up. For the isotopes question, simply look at your periodic table and go through all of the elements listed. Note the atomic numbers and the mass numbers and compare those to the ones that I put on the screen. The only one that is off is magnesium, because the mass number for magnesium is typically 24. That's all for now. I hope this video helped you understand nuclide representation better. If you want more practice, feel free to book a tutoring appointment with me or one of the other tutors. Bye!